Hello everyone, welcome to chapter 1, exception handling in Python, part 3, handling exceptions. If exceptions are not handled well in the Python code, then the Python interpreter stops execution at the point where the error occurred. It does not move further in the program. But if we have exception handlers, then we can log the errors in a file, and we can also show a meaningful error message to the user and then logically close the program. Need for exception handling. Exceptions are different types of errors that we may expect in a program. So whenever we expect a potential problem, we place the set of line of code within a try block. And this is because we want to detect some problems if there are any errors occurring. Now, when a problem is detected, we try to handle it using an except block, and typically it's called an exception handler. So we are managing the problem and we are gracefully closing the program execution. It could be either a built-in error or it can be a user-defined or a custom exception. The process of handling exception. So there are three major concepts here. So first one is called an exception object, then throwing and catching. So exception object is created whenever there is an error, either by the interpreter or the programmer can raise it in the code. Typically in the object, it will have details like what type of exception it is, which file it occurred, which position it occurred, and then it throws. And while throwing, we pass this exception object to the Python interpreter for handling of that exception. And in the throw, it also looks for any event handler available. So the control will pass from the current line where the exception was raised. It will not proceed with the further lines in that block. It will directly go to the handler if it exists. If it does not exist, then it is shown in the output as an error and the program execution is halted. And this is the catch part. So in the catch part, the exception handler is searched. So typically there will be a call stack. We will see that in the later part of this video. Typically stack is a abstract data type. So in the stack, if you see, the last in object can be taken as a first object out. So last in, first out, or first in, last out. So you can imagine a bookshelf or a clothes wardrobe shelf as a stack where we cannot put the bottommost item directly. We have to take the topmost first and then reach to the bottommost. So we try to pop the event handler from the top of the stack. If it's not available, it will go to the next method and so on and so forth. We'll see that shortly in the later part of this video. Now let's look at the process of handling exceptions. I have a program here and the topmost method is called main. And this is the entry point. The program starts by calling the main method. And within the main method, I have a try block, except blocks as well. So there are two except blocks, one catching a specific exception, which is zero division error. The other trying to catch an exception, which is generic, which is of a generic exception type. So any exception other than the zero division error would be caught in this block. Now within the try block, what I'm trying to do is I'm trying to call another method called get total score, which is shown here. So this is another intermediate function. In this method, I'm trying to get the total score from the user, and then I'm also getting the number of subjects from the user, and then I'm trying to calculate the average by calling the calculate average method, which is the deepest method that we have here. So which takes total scores and number of scores, it tries a division, and then it rounds it to the nearest two decimals, and then returns it back to the caller. And then this method returns the value back to the main method. So on the main method, we are trying to print the average score. This is the flow. Now we will look eventually how the exceptions are raised and how they are being handled. Now, let's take a look at the call stack. So what happens is whenever we are calling a method and that method calls another method, a stack is maintained. Stack is usually first in, last out, or last in, first out. So whatever method was called first will be the last method in the stack. So main method was called first, so it is added to the bottom of the stack. On top of that, we have get underscore total score, and then finally you have calculate average score. So any exception raised here can be handled here, or it will try to search for a handler in this method. If it's not available here, it will try to find the handler in this method. So this is the order in which it will work. So it follows the stack model. Now let's take a deeper look into the program that we wrote in the main method. So we have try block, and usually in the try block, what we do is place all lines of code that can potentially result in an error. So when we try to get the score and try to calculate the average, there are a number of errors that are possible. So we are placing it inside try block as a cautionary step. And then we have the exception block. So we have an except block, zero division error, except block for a general exception. So we have a specific exception called zero division error because we anticipate the user might provide zero as a number of subjects, and number of subjects is a denominator. So usually we should not have zero as a denominator. So we have a zero division error, and then we don't know what other exception could happen. So we have a general exception block, and we have a variable E, which we try to print the details by printing the string content of E using the format string, and then we also print the type of the exception object here. Now let's look at some sample execution of the program from an end user perspective. So the first time when we run the program, we provide total score as 450, number of subjects as 5. It calculates the average score as 90.0. In the second run, what we're trying to do is we're trying to send 450 as this total score, but the number of subjects is 0 this time. So now what happens, as you can see, is a zero division error happens, and then we get the message on the output. So this is being handled by one of the except blocks. Now let's try one more scenario where the user enters 450 for total score, but enters A for number of subjects. Clearly, A is not a number. So when we try to typecast it to a number using the int method, we get an exception. The exception is of the type value error. And this is being handled in the generic exception block within the program. Try, except, and else clause. So we'll see a slight different variation of the code that we wrote here on the screen. The variation you will see is there is an else block now available after the exception block, and this line, which was previously after the average score line, is moved into the else block. This is because else block is executed if there is no exception, and this line has to be executed only if there is no exception. So we have moved it into the else block instead of doing it after this line. So what happens is the average score is calculated by the system. If there are no errors, if there are errors, it would go into one of these blocks. If there are no errors, it would print the average score. Finally, clause. Now let's take a look at one more block that we can have potentially, which is a finally block. As you can see, it appears after else block. So interpreter executes the finally block after try, catch, and else block. So this is a block which is executed no matter what happens in the system, right? So and this block is typically used for releasing any resources like file objects you may have opened in the try blocks, that you can close it and release it in the finally block. Now let's take a look at how we can recover and continue using a finally clause. So I've made a small change here. If you look at the main method now, it only has one exception block, which tries to catch zero division error. There is no generic exception anymore. And the remaining program is the same. The source code is similar, but only changes we don't have two exception blocks. We just have one except block in the main method. And then we need to see how the program responds when we try to give an invalid score, like when we type A as the score, right? So we'll see how it works. And we just have else and finally, we don't have a generic exception. Now, if you take a look at the execution, the user provides 450 as a total score, and then he types in A as the number of subjects. Now, A cannot be converted into an integer, so we get an exception. But we get an exception only after we see the cleanup and relinquish resource before leaving in May. So this line of code was written in the finally block. So this gets executed only then the exception is caught by the shell. So now we don't, the exception that has caused here is value error. As you can see, we didn't have a block which handles value error. So remember we had a call stack. In the call stack, it checks if there is an exception handler available for value error, or if there is a generic exception available, generic exception handle available. If both of them are not available, then it goes to the shell and then throws an error on the shell. So now here you can see the error occurred in get total score. This is the top of the call stack. There was no exception handler here. Then it tried to search in the main. Again, there was no general exception or value error exception block. So it threw it to the Python interpreter, and interpreter has printed it on the screen. And as you can see, it clearly tells which file, which line number the location happened, and then what was the call stack.